Mercado math, it's time to do some math. Let's do it. Hey everyone, and we are going to be doing absolute value inequalities. Now, if I'm being honest, I think this is probably the harder thing in the chapter. It's a lot of sign flipping and using absolute values, which some of you might have forgot. If you remember how to do absolute values, this isn't going to be so bad for you. So, we're going to review what an absolute value is. If you remember how to do this, absolute values are basically two equations in one. If you remember how absolute value works, it's distance to 0. So it's asking you, hey, what numbers are 7 away from 0? There's 0, and 7 is 7 away, but also negative 7. So inside here can be 7, or it could be negative 7. What's actually in there is the x plus 5, so we do x plus 5 equals 7, but also x plus 5 equals negative 7. And those were the two little equations that you would solve. Minus 5, x equals 2. Minus 5, x equals negative 12. That was a regular absolute value problem. Something you might remember, you might not. But hopefully, it doesn't look that hard if you did forget. So now if you look, it's very similar to the problem we just did, except instead of an equal sign, it's a less than or equal to sign. The rule's still the same. It's going to be 7 inside of here, and negative 7. So the first one, you are just going to write exactly what you see. X plus 5 less than or equal to 7. Now the issue comes up with the negative. When you solve for the negative, x plus 5 for negative 7, the same reason you had to flip the sign when you divide by negative is the same reason we're going to be talking about this. Negative numbers, the numbers work a little backwards. When you want numbers smaller than 7, that's numbers like 6, 5, 4. Negative 7, it's all reversed. Remember, numbers that are smaller than negative 7 are going to be kind of flipped, so we have to flip the sign. Because negative numbers, remember, negative 5 is actually bigger than negative 7. Negative 8 is smaller than negative 7, so everything's going to be a little backwards again. It's the same idea. But the big rule is this flip. So the main rule here, when you solve for a negative, flip the sign. Okay, that's going to be the big rule. At the end of the examples, I'll put all the rules up here, something that you might want to just be able to fast forward to. Minus 5, minus 5. X less than or equal to 7 minus 5 is 2. Minus 5, x greater than or equal to negative 12. And if you look, you have the same numbers that you had before with the equation, except these are inequalities. And we're not done yet. This isn't even my answer. We're going to graph this, because when I was your age, to be honest, I found it easier to graph it and then write the answer. 2, negative 12. So here's 0. There's 2. Negative 12 is all the way over here on the left. And we go, all right. At 2, it's a closed circle. X is less than or equal to, so we're going to go to the left because small numbers are to the left. At negative 12, it's a closed circle. X is greater than, so we're going to go to the right. And hopefully you kind of remember what this is. From compounds, this is an and statement. So we're going to color this all in. And that's an and statement. That's the graph. Still need my answer. If you remember how an and statement works, great. If you don't, you kind of just mush these together and make one problem, because and means you want things together, so you want your answers together. The easiest way I always found to do this is, like I said, from the graph, small number on the left side, big number on the right side, in the middle goes x, and then some less than signs. Okay? Anytime you have absolute value is less than, it's going to be an and statement. This is my answer. This is not an answer. Putting the word and between them is not the answer. This is what your answer should look like. Okay, and if you look, it's what you have. If you cover this up, x less than or equal to 2. It's exactly the same thing. Over here, it's a little reverse, saying x is larger than negative 12. This one's saying negative 12 is smaller than x. But if you look here, negative 12 right above, 2 right above, your answer's all that crap in the middle. X is your answer, that's why it's in the middle. Less than or equal to signs, you can just throw it in there. That's from compound, so hopefully you remember that. If you don't, I mean, we're going to do more, so it'll come back to you. So here we go. We have a absolute value of 2x plus 8 greater than 10. I'm going to solve my 2 because inside of here can be 10 or it could be negative 10. Remember, you're doing 2 problems for 1. That was kind of the whole idea of absolute value. 2x plus 8 greater than 10. That first one, you're literally just writing what you see. When you solve for the negative, this is the big move. This is literally the thing that screws people up the most. When you solve for the negative, you flip the sign. So it's still going to be 2x plus 8. It's just now that I'm solving for the negative, the sign gets flipped, and it's for negative 10. Okay? When you solve for the negative, you flip the sign. That's the big rule for this section. Once you're here, we're just going to go about our business and solve these both. Minus 8, minus 8. 2x is greater than 2. We divide by 2. Divide by 2. X is greater than 1. Great. Grand. Wonderful. It's going to be the exact same steps here, guys. Minus 8. Minus 8, because it's the same problem, pretty much. 2x is less than, same sign. I add, keep the sign. Once you're there, divide by 2. Divide by 2. X is less than negative 9. Now, I already know what it's going to be, so I know how to write this answer. But like I said, I think for a lot of you, you're going to want to graph it. And then once you graph it, you might be able to see what your answer actually is. So I'm going to graph this guy. We're at 1 and negative 9. So there's 1 on my right. Negative 9 is all the way on the left. And we go, okay, I have open circle at 1. Open circle. X is greater than 1. Greater than, we go to the right. X is less than negative 9. So at negative 9, open circle. X is less than, goes to the left. And hopefully you see that it's going out, and that's an or statement. If you remember or statements, they go out. And statements go in, or statements go out, like boat oars. Or statements most people find a little easier, because all you have to do for an or statement is make sure the word or is there. So for me, that's my answer. It's one answer, not 2 separate answers. It is one answer with just 2 parts. You want numbers that are larger than 1 or smaller than negative 9, okay? And like I said, the shortcut for this one that I remembered, if you have an absolute value that's greater than, I remember the or. Greater than. So I'm going to give you the rules up now. And like I said, I think the rules are pretty simple. And then I'll give you some examples for you to try on your own that I'll also go over. Okay, so these are the rules. This is a little more official of a definition as far as just when you solve for the negative, flip the sign. Some people, when they hear the word sign, they think that means the negative. It's actually the inequality. You'll hear me say sign a lot. It's a little simpler. But when you solve an absolute value inequality for the negative, you have to flip the inequality. Meaning if it's greater than, you flip it to less than. If it's less than, you flip it to greater than. Only when you solve for that negative. That's the key thing. When you solve for that negative, you have to flip the inequality, okay? It's one of those rules. It's easy to forget. Once you do it a few times, though, you realize, oh crap, there's something weird about this one for negatives, and it's the sign flip. Negatives and inequalities always get a little weird because of that the way the numbered line works. Everything's a little backwards when you deal with negatives. When you have the absolute value less than a number or less than or equal to, depending whatever the situation is, it's going to be an and statement. You could remember that. Like I said, when I was your age, to be honest, I would graph it and then figure it out. But eventually I figured this out on my own, and I don't think I figured this out in 9th grade, though, or no one told me. This is one of those things you just kind of, I learned on my own. When I have the absolute value greater than a number, or greater than or equal to, it's going to be an or statement, and I always just taught myself to remember greater than. You have to kind of say it like an idiot, greater than, but it really did help me remember, and then I knew if it was a greater than, it was going to be an or statement, greater than sign, or statement, greater, and the other one would be and statement. Less than would be an and. You could say less than. That sounds really bad, and technically this is also greater than, so that's interchangeable. So greater than, greater, all right? It's going to be an or statement, greater. That's one way to remember it. Or, like I said, to be honest, when I was your age, I would have to graph it. And then once I graphed it, I'd see it, whether it was an and or an or statement, because no one ever taught me these shortcuts. So, like I said, if you can remember the shortcut, your life gets a little bit easier. If you don't know the shortcut, you can still do this stuff, guys. This isn't something you necessarily, you don't have to sound like an idiot to do this stuff. You can do it, graph it, and then go, oh, it's an and statement. Write your answer. You can do it, oh, it's an or statement. Put the damn word or between the numbers. All right? Pretty simple stuff. Let's let's do some examples. So we have absolute value of 6 plus 2x greater than or equal to 20. Now, I know the shortcuts, so I see this greater than sign, and I know it's going to be an or statement. I know that ahead of time, because if I screw up, usually flipping the sign, I'm going to know what I screwed up. I know this graph should be going out. It should be going left and right, going out like boat oars, because I know it's a greater than sign, or. If you don't know, we're going to go like you don't. This inside here can be 20 or negative 20. That's right out of chapter 2, absolute values. 6 plus 2x greater than or equal to 20. The first inequality is literally what you see. When you solve for the negative, this is the big rule. When you solve for that negative 20, you flip the sign. This greater than sign is going to flip and become a less than or equal to sign. That's the big move. If you can handle that, this isn't really much work. It is 4 steps of work. To get x by itself, I'm going to do minus 6. Remember, get rid of what's furthest away, but on the same side. Whatever you do to one side, we do to the other. That's a 2x greater than or equal to 20 minus 6 is 14. We divide by 2. Divide by 2, and we get x greater than or equal to 7. That's one of them. Same thing here. I want to get x by itself. Minus 6, minus 6. 2x less than or equal to negative 20 minus 6, negative 26. Divide by 2, divide by 2. X less than or equal to negative 13. Those are my 2 answers, and once again, because I know what it's going to be, I can write my answer right now if I wanted to. If you don't know if it's going to be an and or an or, you might have to wait. But deep down, greater than sign, I know it's an or. So I can put the word or there, I can box my answers, and I'm done. My graph, though, because you almost always have to graph for this crap. Graph, we have 0. I like to put 0 all the time. Here's 7. Negative 13 a lot further on the left. For my graph, at 7, it's a closed circle, greater than or equal to, so closed circle. And once again, I know it's an or statement because of greater than, so I know this should be going to your right. I know this should be going right. X is greater than, and it does. Goes to the right. That's what I was expecting. I know this is an or statement. I know this one should go to the left. Closed circle at negative 13. And this is where, if you screw this up, if you forgot to flip this sign, you would hopefully notice because you know it's supposed to be an or statement. This is where knowing what it is could help you. X is less than or equal to, less than goes to the left. That's what I wanted. That's what I was expecting from an or statement. If this had gone to the right, that means you probably forgot to flip the sign. That's the big mistake. That's what people usually screw up. All right? That's one example. Let's do another. Alright, so for this one, this is going to be probably the hardest one that we do. And to be honest, this is about as hard as these get. And we'll talk about why. It doesn't mean you can't do it, it's just there's a lot of room for error on this one. We're going to start the way we always do. Can be 6, negative 6. Negative 3x plus 12 less than 6. That first one, same thing you read right there in black. The second one is where I solve for that negative sign, negative 3x plus 12. I'm going to solve for negative 6, and when I solve for the negative, I flip the sign, that less than, greater than now. Once you're here, we are going to write minus 12, negative 3x less than negative 6. Everything's falling. When I divide by this negative 3, this was that big rule in the chapter. When you divide by a negative, you flip the sign. So I had to flip the sign here. Greater than 2. Over here, I'm going to subtract 12. Negative 3x greater than negative 18. Divide by negative 3. When you divide by a negative, you flip the sign. X less than, that sign just got flipped, positive 6. And hopefully you kind of realize why this one is considered harder. I just flipped this sign 3 damn times. I had to flip it here, because that's the big rule for this section. When you solve for the negative, you flip it. Then I had to flip it here when I divided by negative 3, which I did on the left side and the right side. That's 3 sign flips. There's a very good chance, if you're flipping a sign that many times, you might forget one. So this is about as hard as that gets. If you can remember those rules, though, you're set, because that was a very big rule in the chapter. Now I know what this should look like. I know it's a less than sign. Greater than. If it's a greater than sign, it's an or, which means this has to be an and statement, okay? Because greater than, greater, less than, and. I'm going to graph it just to make sure I didn't screw anything up. A lot of sign flips. At 2 and 6. All right? 2, 3, 4, 5, 6. What the hell? I'll draw all of them. At 2, it's an open circle. Doesn't equal, just an open circle. X is greater than, so it goes to the right. Forever and ever and ever, just keeps going to the right. At 6, it's an open circle. Goes to the left. X is less than, goes to the left. Forever and ever, goes to the left. Because it's an and statement, you want that overlap where both lines overlap. This nice section in the middle. Okay? That is your and statement. Like I said, I could erase these arrows. That's kind of just extra crap now. That is my and statement. That's my graph. That's part of my answer. These 2 loose pieces are not my answer. It's an and statement. I want them together. You basically have to push them together. So my answer, I'll write it up here where there's a little more space. Like I said, your answer kind of goes off the graph. Like I said, when I was your age, I did the graph, then the answer, because I found it a little easier. Small number on the left, 2. Big number on the right, 6. X goes in the middle because your answer is all that crap in the middle. And if you realize, you would just put those less than signs, because less than signs and and statements really do kind of go together. And these 2 should match. This one matches exactly the same. X less than 6. It's exactly the same. This one, for the 2 less than x, it's a little different. Because once again, this is saying x is bigger. This is saying 2 is smaller. Same idea, 2 different perspectives. I'm older than you versus you're younger than me. It's the same information, just taken 2 ways. This is how you write an and statement. And statements, for the most part, because of that, are a little harder. People have a little more trouble writing this than they do just putting the word or. But once again, not bad, because if you look, this is kind of set up that way. You have the 2 on the left side, the 6 in the middle, there's x. Less than signs, I mean, there's your answer right there. Obviously, you don't want to write it like that. You write it separate. Okay, hopefully that's not so bad. And, yeah, let's draw something. Greater, because great job today, guys. Ha ha ha!